Okay, let's dive straight into something that's completely transforming how we build software. We're looking at how AI is reshaping development, specifically through the lens of this company called Cursor.
That's right. And, our source material for this deep dive, it's not some dense paper. It actually comes straight from an interview with the Cursor team themselves on Anthropic's YouTube channel. It gives a really candid look inside.
Exactly. So our mission today is pretty simple.
Hmm.
We want to cut through the noise, pull out the absolute key insights from that conversation. We want to understand what exactly is fueling this unbelievably rapid change in coding,
Hmm.
and maybe uncover some surprising facts about where AI is taking software engineering.
Sure.
Basically, give you a fast track to being genuinely well-informed on this, super dynamic topic.
And you hit on rapid, that's definitely where we should start. One of the first things that just leaps out is Cursor's explosive growth. I mean, scaling to over $300 million revenue, millions of developers using it.
In just over a year.
Yeah, just over a year. That kind of adoption, it doesn't happen with just a minor tweak. Something fundamental shifted.
Seriously. And the Cursor team, they're pretty clear about what that shift was.
Hmm.
Initially, Cursor was already good, right?
Hmm.
Helpful features like basic tab completion, speeding up typing, and helping with edits inside a single file. Useful stuff.
Useful, yeah, but maybe not the kind of thing that gets millions of developers switching overnight.
Exactly. The big moment, the point they actually called the step function.
Yeah.
That came with genuinely better large language models.
Right. They specifically mentioned models like Claude 3.5 Sonnet. This new generation, it just had this step change in capability. It let Cursor kind of close the gap between what AI could potentially do and what was actually practical and reliable for developers day to day.
And the crucial capability, the one that really unlocked things for them with models like 3.5 Sonnet.
Multi-file edits.
Ah,
Before, asking an AI to understand and make coherent changes across, several different files was just incredibly tough. But with these better models, it became much more viable. And that ability to handle multi-file tasks, that was a massive driver for mass adoption.
makes sense.
Absolutely. And it's not like it stopped there. It's this continuous dynamic thing. On one hand, the models just keep getting better. You've got the new Opus 4, Sonnet 4 coming out now. And on the other hand, Cursor is constantly tinkering, constantly pushing how far they can actually leverage these models. They're integrating more sophisticated workflows, like tool use.
Okay, so tool use, and they also mentioned agentic types of coding. What do those actually mean here?
Good question. So tool use, basically it means the model isn't just spitting out text or code suggestions. It can actually interact with the dev environment. It can use tools, run tests, look up docs, maybe use the terminal based on your instructions.
Got it. So it's taking actions.
Exactly. And agentic coding sort of builds on that. It means the AI can take on more complex tasks, maybe involving multiple steps, multiple tool interactions. It acts less like just a co-pilot suggesting the next word and more like a semi-autonomous agent trying to achieve a goal you set.
That makes sense. It's not just predicting text, it's actually doing things.
Yeah.
Which, brings us to one of the most fascinating bits they talked about. Cursor, using its own tool to build itself.
Yeah.
This self-improving recursive feedback loop.
It's like they're their own ultimate power users, right? They're constantly dog-fooding their own product. And what's really interesting is how they describe using it internally. It varies quite a bit.
Yeah, it depends on the person, the stage of the project.
Exactly.
Like if they're starting something totally new, a new code base,
Yeah.
laying out a big new feature, they said their agent feature is super useful then. Gets that initial structure, the boilerplate code, set up really quickly.
But then, say they're debugging a specific tricky block of code. They might switch modes. They might rely more on what they called thinking models. Models may be optimized for deeper analysis of a specific piece of logic.
Right, and then for just making very precise edits in code they know really well.
Back to the tab feature. Basically, super intelligent autocomplete just speeds up typing the code they already know they want.
Okay, and what about when they hit something totally unfamiliar, like a big legacy system or some open source library they haven't touched?
Yeah, for that, they lean heavily on what they called QA features and search. They specifically mention leveraging models like Claude 3.7 and 3.5 Sonnet, which are known for having those big context windows.
Right, they can ingest a lot of code.
Exactly. They can synthesize information from huge code bases really well, helps navigate the unfamiliar.
So these QA features, is that like a specific Cursor tool name?
Yeah.
Or just a category?
It sounds like their internal term, yeah. Features designed to help you query and understand a code base. Think asking the AI stuff like, where's this function used? Or how does this part connect to that part? Or just Explain this chunk of code to me.
Okay. Query and answer, maybe?
Yeah, Q&A, something like that. Makes sense. They didn't define it precisely, but that seems to be the function.
Gotcha. And this internal use, this constant dogfooding, it must give them a huge advantage, right?
Oh, 100%. They were really firm on this. Being their own primary user means they can try new stuff instantly. They get brutally honest feedback from their own team, who are all expert developers.
And crucially, they can just throw away things that clearly don't work
Yeah.
internally before it ever hits users.
Yeah, it massively speeds up their iteration loop. Build, test, refine super fast, based on real usage by people who deeply understand the problems themselves.
It really highlights something important, doesn't it?
Mhm.
AI help for developers isn't just one thing.
Exactly. The Cursor team really stressed this. How a developer uses AI varies hugely. Depends on how well you know the code, what you're trying to do.
Right, the whole spectrum. Like,
Right.
at one end, you've got tab. That's when you're totally in control. You know what you want. You just want to type faster.
Moving along, you've got Command K. That seems to be more for editing within a specific region, maybe a function, maybe a whole file. You give it a prompt like, refactor this to handle errors better, or add some logging here, more guided than tab.
Then you get to the agent feature. That sounds like it's for the bigger stuff, tasks that might touch multiple files, like telling it, implement this new API endpoint,
Mhm.
which needs changes in routers, controllers,
Yeah.
models, all over the place.
Yeah. And then at the very, very far end of that spectrum is something newer they're previewing,
Right.
the background agent. They're even talking about this potentially handling entire PRs.
Entire pull requests. Wow.
Yeah, whole chunks of work, maybe adding a small feature, fixing a bigger bug, all potentially handled by this background agent.
Okay, so what is this background agent? And why do they need it if the models are getting so good anyway? Can't they just do the whole PR directly?
Well, that's the thing. The models are getting much better fast, but they're still not 100% reliable for really complex end-to-end tasks, especially in messy real-world code. So the background agent, it addresses this by letting developers work on these big tasks in parallel.
So it's like concurrency for coding assistance.
Exactly. You give a prompt for a task to the background agent, push it off, and it just starts working on it independently. They mentioned it runs in these small enough independent environments, basically little isolated mini-dev setups.
With all the tools it needs.
Yeah, containing developer environment utilities, VS Code extensions, things like linters, formatters, test runners, whatever the agent might need to use.
Okay, so it's chugging away back there, maybe even running tests itself in its little sandbox. What happens if it, messes up or only gets part way?
And that's the key part. If the background agent's output isn't perfect, and often it won't be, especially for complex stuff the developer isn't blocked, they can keep doing their main work, then, when they're ready, they can pull the agent's progress into their main foreground environment.
And then fix it up.
Exactly. Use Cursor's other features, Command K, Tab, whatever, to quickly refine it, correct the mistakes, finish it off.
They called this a new primitive. That sounds pretty
yeah.
fundamental. What does that imply?
Yeah, primitive is a strong word, like a basic building block. They see this ability to offload a complex coding task to an independent agent running in the background as a new fundamental way of working. They were imagining scenarios where developers might be operating on like 3 or 4 changes at the same time.
Whoa.
Yeah, quickly switching focus between different background tasks and their own foreground work, almost like juggling multiple coding projects at once.
Wow. Okay, so if developers can suddenly write code way faster using these agents working in parallel, what does that do to the whole software process? They talked about bottlenecks shifting, didn't they?
Absolutely. Their prediction was, if these parallel agents become common, the main constraint on engineering speed won't be writing the code anymore.
Right. It shifts somewhere else.
Shifts to verification of software, verification of code, and especially reviewing code.
The code review bottleneck.
Think about it simply, like they hinted. If writing code is, say, 70% of your time now, and review verification is 30%, even if AI makes writing instantaneous, you've only sped up the total time by, a factor of 3, roughly, 113.
Right, you hit the review wall.
To get those really big exponential speedups, you have to tackle verification and review, make them much faster too.
And that challenge of correctness, it's tricky, isn't it? They said it's kind of vague. Tests are good, but passing tests doesn't always mean it's right.
Exactly. Doesn't mean it matches what was in the developer's mind's eye, or fits the subtle requirements, the architecture, the style.
Automated tests catch the objective bugs, but not the subjective stuff.
Precisely. They talked about some early ideas for improving verification, maybe operating on a different, more concise representation of the change, like pseudocode, or maybe a diff of a high-level plan, with some kind of guarantee that this plan maps cleanly to the actual code changes the AI makes. Easier to review the plan than lines of code.
They contrasted that with vibe coding verification.
Yeah, which works for small stuff, right? Just run it. Does it feel right?
Good luck doing that in a massive, real production code base.
Exactly. Way harder. So the focus shifts. How do we make that complex verification and review process faster, maybe even AI assisted?
This all sounds plausible for maybe smaller projects or starting fresh. But what about those huge, old, gnarly enterprise code bases?
Yeah.
Millions of lines, complex dependencies. That feels like a different beast entirely for AI.
It totally is, and they address that directly. Two big problems they see. Problem one is just setting up the environment, getting all the dependencies right so an agent can even run tests or build the code in some massive system.
Right, the setup nightmare.
They think the background agent approach, with its ability to create and snapshot these repeatable, isolated environments, is a key part of solving that. Makes it easier.
Okay, so maybe the environment setup gets easier.
Right.
But what about just understanding the code itself?
Yeah, problem two. Big code bases aren't just big. They have their own weird patterns, custom mini languages, DSLs they called them, and the knowledge is spread everywhere. Hundreds of millions of tokens maybe, just grabbing files based on keywords, standard retrieval. It's insufficient, doesn't cut it.
So what are they doing? Just hoping the models get infinitely smarter?
They're going beyond simple retrieval. They mentioned working on training better, more sophisticated retrieval models, and crucially, integrating other sources of context. Things like, what has this user been working on recently? What have their teammates changed? That gives clues.
Using recent activity as context. Smart.
And it's not just about the AI understanding the code well enough to make it work, like past tests. It's about understanding how we do things here.
Well, doing it the right way problem.
Yeah, matching the existing style, the structure, using the right internal libraries.
They had that debounce example, right?
Exactly. An AI could write a perfectly functional debounce function from scratch, but in a big company, there's probably already an approved, tested internal one, maybe 3 or 4 slightly different versions. The right way isn't writing a new one, it's finding and using the correct existing one. And knowing which one that is often requires context outside the code itself.
Which leads straight into that org knowledge factor they brought up.
Mm-hmm.
Some of the really critical stuff, the how you do it, isn't even in the code base. It's in Slack messages, design docs, tribal knowledge.
Exactly. And they see that as a potential future bottleneck.
Yeah.
Let's say the AI gets perfect at understanding the code. The next limit is plugging in all that external human organizational context.
And integrating those outside systems, the business side, sales tools, team chats, into something like Cursor.
They admitted that's still some ways away, a hard problem.
Okay, yeah, that makes sense. It's a boundary. Shifting gears a bit, they had this really interesting thought. Will code itself start to change? Like, get optimized for an LLM to read it, the way web pages change for search engines?
They said basically, yeah, totally the case already.
Oh, really? How? Give me an example.
They mentioned API design, things like making version numbers or compatibility requirements really explicit and clearly structured. So a model parsing the code or the docs is much less likely to get confused about which version it should be targeting or using.
Ah, okay. So structuring code not just for humans or compilers, but specifically to make it less ambiguous for an AI assistant.
Right. The general idea is structuring code to reduce the number of sort of interaction levels or steps a model needs to understand or modify it. Simpler, flatter structures often seem easier for current models.
But they did add the caveat that, the principles of clean software are not that different for humans and AIs.
Yeah, things like DRY, don't repeat yourself, simplicity, modularity, those help everyone, human or machine.
Which leads to their point about taste in code becoming even more important.
Exactly. If AI makes writing the code trivial, the valuable skill becomes deciding what code to write, how it should be structured, what's an elegant solution, what's maintainable. That judgment, that architectural taste, becomes critical when you can generate vast amounts of code easily.
That connects directly to that common worry you hear, right?
Yeah.
Will these tools just make programmers lazy? Or maybe worse, stop juniors from really learning the fundamentals?
Yeah, they pushed back on that pretty hard. They argued these tools are actually very good educationally. Their point was you can instantly ask the AI to explain things. You hit, Command L and ask Claude, what is this? How does this function work? Why is it like this?
It's like having a patient expert tutor always available.
Right. Instead of getting stuck digging through docs or trying to piece it together yourself, you just ask the tool you're already in.
Okay, that's a fair point.
And they also argued that models vastly accelerate this iteration process because it's faster to write code and see if it works. You can learn more quickly what works and what doesn't. You make mistakes faster, get feedback faster. It speeds up that whole experimental loop that's so crucial for learning.
So not making you lazy, just compressing the learning cycle.
Yeah.
Okay, so what do they think this means for the actual role of a developer long term?
Well, they believe we'll still need engineers who really know the details, who can go into the weeds on performance, systems, tricky logic for a long time. But they did speculate we might see a sort of new class of engineer emerge, someone who maybe needs to know very few of like the low-level details and operates at a much higher level.
Higher level.
Yeah.
What does that look like?
They described it as maybe focusing less on writing the specific implementation code and more on defining the desired behavior.
Wow.
Or focusing on the UX taste, like describing in detail how a complex UI should react, or specifying the steps in a business workflow, and the AI handles generating the underlying code to make that happen.
More focus on the what and the why, less on the nitty-gritty how of the code itself.
Something like that, yeah.
Interesting. Okay, switching slightly, the Cursor team also talked about the brand new Anthropic models, Opus 4 and Sonnet 4. What were their first impressions?
Pretty enthusiastic, especially about Sonnet 4. They used the phrase, pretty shocked.
Shocked good, I assume.
Yeah, shocked good. They said it has effectively fixed all those little nagging issues they saw in the previous version, 3.5 Sonnet. Things like it being occasionally too overeager with changes or sometimes subtly changing tests when it shouldn't have.
Wow, fixing those kinds of subtle reasoning flaws sounds like a big jump.
It really does. They called it a big step up in intelligence, in capability. Said it's going toe-to-toe with models like Opus 3, the previous top-tier model, but it's much cheaper to run.
That's a powerful combination, and Opus 4.
They're super excited about that too. Saw it as a fantastic agent to use in the background for those more complex autonomous tasks we were talking about.
And from Anthropic's perspective, why are they pouring so much effort into coding specifically?
Well, they see it as a really critical capability. They mentioned that coding skill has a good amount of transfer to general reasoning, like reasoning overtaking many actions, working in an agentic way. Coding is a great testbed for teaching models to plan, execute steps, use tools, correct errors, skills needed for lots of other tasks.
Makes sense. A structured domain to learn complex reasoning.
Exactly. And Anthropic is already pushing into other frontiers, like computer use, teaching models to navigate human interfaces just by looking at screen images. They also mentioned focusing on the model's character, trying to make Claude feel less like just a tool and more like a confidant, someone you collaborate with closely.
Interesting. Okay, let's bring it all together then, the big picture view. The overwhelming feeling from this interview seems to be AI is augmenting engineers, not replacing them.
Yeah, allowing them to do more than ever, make prototypes, spin up demos super fast. And your existing coding knowledge isn't wasted. Actually, it helps you exploit it much better.
Right, that taste, that understanding lets you guide the AI effectively. And they made a pretty bold prediction for the near future, didn't they?
They did, for January 1st, 2027. So not that far away.
What do they predict for that?
100%, or close to 100% of code will have AI involved in creating it somehow.
Yay.
Yeah. They used the analogy of asking back in, say, 1995, what percentage of legal documents would be generated using a word processor? Pretty much all of them, right? They see AI in coding becoming just as ubiquitous, just part of the standard workflow.
So it's not if AI is involved, but how. And in that world, the developer's role really changes.
Exactly. The role of understanding the requirements, understanding what the code needs to do, having that architectural taste, and guiding what is done becomes even more critical than just typing syntax.
And they back this up with their own internal use at Cursor, right?
Yeah, they said already today, 90% plus of the code they write internally involves using one of their AI features, Agent, Command K, even just tab completion. The amount of actual letters typed by humans is already a very low percent.
That's quite a stat. It shows how fast this is happening, at least for them.
And it points to another massive potential outcome. Software on demand?
Meaning
People who aren't traditional software engineers can suddenly start building their own tools. They gave examples like people on their sales team building their own custom dashboards.
using these AI tools.
Yeah. The bottleneck stops being the technical skill of coding and becomes simply having a unique idea for a tool or a system that you need.
That could unlock a lot of productivity, a lot of niche solutions.
Absolutely. They even shared this great anecdote about someone on their comms team communications who is now apparently shipping bug fixes to Claude.ai using AI tools, someone completely outside engineering, contributing directly to production code.
That's incredible.
Yeah.
It really illustrates how the barrier to building software is potentially dropping dramatically.
And they even speculated about a crazy future where software might dynamically change itself for individual users. Based on how you interact with it, it adapts to your needs. Without you explicitly building anything, the AI just tailors the software on the fly.
My mind-bending stuff, software that evolves for you.
Yeah, definitely out there, but interesting to think about.
So finally, they had some career advice for talented engineers watching all of this unfold.
Yeah, they basically argued that being at startups right at the cutting edge, like Cursor or Anthropic, offers a huge advantage right now, mainly because of the high talent density. You're surrounded by really smart people working on genuinely really impactful things in incredibly small teams.
You get to be part of fundamentally changing how software gets built.
Exactly. Being right at the forefront seems to be the key takeaway.
Makes sense. Be where the change is happening most intensely.
Right.
Okay, so for you listening, here's maybe a thought to chew on after hearing all this. If they're right, and by 2027, pretty much all code involves AI, and the most valuable skills shift from typing code to verifying it, guiding it, having that architectural taste. How does that change how you think about learning to code today? Or what skills should you be prioritizing over the next few years? And what does it really mean for innovation when almost anyone with a good idea might be able to build their own software on demand? A lot to think about there.